I'm the head of the information management department at IQWIC. I'm an information specialist. I'm going to talk about machine learning and also about AI studies. To give you an overview where I'm working, I work at IQWIC. It's a scientifically independent HTA institution in Germany. We examine the benefit and harms of medical interventions, and we do that evidence-based. So basically, we do systematic reviews on all different kind of topics, like drugs, medical devices in all kind of shapes and sizes or topics. So we have something from everything. And we information specialists, we have a team of 8 information specialists and also 4 librarians. We also are responsible for the study selection process. We do not do the selection process, but we are responsible for the technical things around the study selection process. So what are we talking about today? Study selection process, we also call that screening. And the methodological standard is you have to do that after the information retrieval took place, like searching in databases, gathering everything together. You have your results. And these results with citations, you have to screen them. And this selection steps, there are several: title, abstract, full text. You have to perform them by 2 persons independently of each other, and discrepancies are resolved by discussion. Obviously, because you have to do them by 2 persons independently, this is a huge workload. And if AI could help with that, there would be a lot of time savings possible. As a rule of thumb, if you have 1,000 citations, for example, in a search, then these 1,000 citations have to be selected or screened by 2 persons independently, and round about 900 of them will be excluded. After that, 100 full texts has to be further examined. And after that, roundabout, it's really only a rule of thumb, 10 will be included. At IQWIC, we do around about 200 to 300 searches per year, and we have from 100 citations up to 5,000 mostly. Only in exceptional cases, we have searches with more than 5,000 hits. But I know I already seen systematic reviews with 25,000 citations, and you can imagine what kind of work that is. At IQWIC, we use a screening tool provided by Evidence Prime. It's based on laser AI, but we have a customized tool what we are working on. In the past, we worked on this methodological standard. For example, a few years back, we did a prospective validation study on machine learning, where we compared the different prioritization tools that were available at that time. We compared EPI Reviewer with Ryan, and we found out in our study that the systems were able, after screening 50% of all citations, that the systems were able to get 88% of the relevant citations or the relevant studies, and Ryan 66%. We at IQWIC, we concluded that 88% is not enough for us to really stop screening with 2 people independently, and we wanted to wait until we have better numbers. Yeah, and that's why we are interested what AI is doing in terms of screening. As an introduction, I also wanted to point out what is AI exactly. So I would say artificial intelligence is everything. That also includes machine learning and also deep learning, and large language models are part of deep learning, but also natural language processing. And so there's no really distinction. But in the last year or two, in our day-to-day language, we would say artificial intelligence and would mean large language models. So that is something that shifted. And I think I'm also using in this presentation AI to speak about large language models. In my presentation in June, I really focused on machine learning approaches that are available right now, but I'm going to skip a little bit more quickly through these slides. So for machine learning approaches, there are three different categories available. There is ranking, and most of the screening tools have ranking implemented. It's an active learning algorithm. Then there is pre-trained classifiers like Robert Search and Appy Reviewer have these pre-trained classifiers included. And there's also another category that is called clustering, but that's not that often that you could see that. And now I want to talk about what is the difference between machine learning and large language models. And for example, machine learning, you will get reproducible results. They would build custom screening algorithms for topics or for study types, for example. They have moderate algorithm size. Some of them are validated, and the training data is transparent. But on the other side, the large language models, they are not perfectly reproducible right now. And large language models predict the similarity and the co-occurrence of words. So it works differently when as these custom screening algorithms. These algorithms are very large. They are not validated at the moment, and training data is unknown and intransparent. These are the foundation models in comparison that are available right now and were used in the studies I'm going to show you in a few slides. Most of them use ChatGPT, Claude, Gemini, and Llama. And the foundation models on the left side, they are free if you use them via the web interface, but there's also a fee-based API available. And of course, I included DeepSeek, that is very small, new, and yeah, not so expensive as the other ones. The different large language models differ in size, in input, and how they generate answers. They could run on smartphones, on personal computers, but if they are much bigger, then they run on special servers only, and then you would access them via API. The input could also differ, like includes text. That's important for us, but they are also could include PDFs, multiple PDFs, images, videos, spreadsheets. And there's also a difference how they generate answers. There are different kind of prompting like zero shot or chain of thoughts, but there are also different approaches like retrieval augmented generation. And the different approaches I'm going to show you later on. So I want to start in talking about what the literature says about machine learning. 1 year ago, when I did this presentation, there were 2 systematic reviews that combined all the machine learning algorithms that are available when we talk about systematic reviews, and most of them assist in screening. There are a lot of screening tools available that use machine learning, and the ones highlighted in green, according to Khalil, are validated. But as a conclusion, you could say that the practical application is there are 2 publications who assess that. And in a summary, you could say there's no significant uptake in systematic reviews so far. And there was also another systematic review that tested the accuracy or gathered the accuracy of machine learning screening. They included 71 studies. That's really impressive. And the combined recall was 93% or sensitivity. And even when they tried to assess or to run different subgroup analysis, like different number of hits or a special size of included studies, they were not able to get a recall or sensitivity above 95%. And 95% sensitivity is really an important threshold in information retrieval. For example, all the study filters that are available, it's really important to get above this number of 95% if your goal is to get a complete picture of the evidence base. So this systematic review also concluded that the recall or sensitivity should be above 95%, and this it should be prioritized to work on that. And they stated that at the current stage, manual literature screening is still indispensable. So now we are going to talk about where are we going? Where are we now? What is going on with all these large language model studies? There are a lot. And I'm not really, what I'm talking about now, I did not do a systematic reviews on all studies available. Of course, I did a search and I checked other publications, but this is not really a complete picture. To give you an example what these studies did, they are mostly different, but they have a few things that are similar. I wanted to show you or present you in detail the study TRAN 2024. I've chosen this one because the study was done by a few Cochrane authors. And I think they really were transparent in what they did and how they gained their results. So I wanted to show you this study. They did a retrospective diagnostic study. As an index test, they used ChatGPT 3.5, and as a reference standard, they used conventional consensus title abstract double screening. They used as a test set 5 systematic reviews, and in total, they had over 23,000 citations that they tested. They used zero-shot prompting chaining with instructions to provide reason for each pico element. That means that for each pico element, they used a zero-shot prompt, so one prompt for each pico element, and the system had to answer each one of these prompts. And the results were interpreted in 2 ways. They used a balanced interpretation, where even when the system excluded one of these pico elements, then the study was included. And they also had a sensitive interpretation where 2 of these 5 prompts could be excluded, and even then it was included overall. This is an example of the zero-shot prompt for the population. It's like that, as you could see. And these are the results. For the balance interpretation, they reach a sensitivity of 81 up to 97%, and specificity was 25 to 80%. Specificity is a really important number. Not only, of course, the sensitivity is the main one, but specificity is also really, I see there's an error. I'm really sorry. Specificity is really important too, because it states the number of references that will be excluded at once. And so this is a really important number to see how how we could benefit from AI or from the large language models. For the sensitive interpretation, they reached 94 to 99% sensitivity, and specificity was, of course, it was lower to up to 47%. They stated that they had workload savings from 54 to 98%, and they also tested the retest reliability and stated that ChatGPT makes different errors over time, but that the overall error rate stayed the same. So now I wanted to give you a summary of the different approaches that were used in these studies. First one, and I already mentioned that, is zero-shot prompting. That means that there is one prompt per screening decision and that the large language model did not get any examples in advance. There is another approach that means few-shot prompting. That's also a single prompt per screening decision, but the system gets one or multiple examples for the correct answer. A lot of the studies available used a combination of zero-shot prompting and prompt chaining. That means they used multiple prompts per screening decisions, and with the goal to break down this complex task of screening the citation into simpler tasks per pico element. Some of them use a chain of thought prompting approach. That means that the system has to give reasons for their answers. And another approach that was used is majority voting. That means that multiple answers from multiple runs were considered. Sometimes they repeated the answer of one large language models and considered that in whole, but sometimes they also used multiple large language models and combined these results. I also wanted to show you examples of these different prompts that were used. This is an example of a zero-shot prompt, and this one on chain of thoughts, how that works. This is an example from OAMI 2024. And this is an example of prompt chaining, so where the task was splitted in different prompts for each of the pico elements. This is an overview of the technical approaches that were used. Most of the studies used API access, and they used programming language like Python, R, Google Apps, or OpenRefine to do the prompts and also to do the whole process. But sometimes they also used chat interface via web application or smartphone app. And I think what also would be possible is indirect access. There was one study that used a tool, new programmed tool. I think we will see that in the future a lot often, more often. Oh my God. And but right now I could see only one screening tool. So I thought about if I should show you the sensitivity performance, and because uh, the different studies are not really comparable, but I wanted to give you an overview, a perspective, what is going on. So these are the sensitivity numbers I could extract from all the different studies. And as you could see, they some of them um, have sensitivity that are not acceptable, like 38%, 42%, 50%. But there are really few of them that could gain sensitivity above 90%, and that's really impressive in such a impressive in such a short time. And these are the specificity performance so far. And what is really surprising is that a lot of studies could gain specificity above 90% as well. And that's really good. To give you another perspective, as I told you before, there is this really important threshold of 95% in terms of study filters in information retrieval. And if this table shows you the different approaches and what numbers they could reach. For example, the gold standard is we really have very good RCT filters available. This one is Wong 2006, Medline, high sensitivity, and they have sensitivity above 99% and reach specificity of 71%. These RCT filters, they are really well known and well used. So this is kind of a gold standard for everything. If you really would, your goal is to reach high sensitivity. And the RCT classifier in comparison also reached 99% sensitivity, but specificity is slightly lower, like 63%. And in comparison, I'm going to show you that TRAN 2024, they reached sensitivity from 81 to 97% sensitivity. So it's not really comparable to a RCT filter or the RCT classifier, because it should be above 95% all the time. So this is a thing they have to work on and should improve. But what's really extraordinary are the specificity numbers. It's 20%, but it's up to 80%. And that is really great, surprisingly great. And what is really interesting to see is that although these studies just were done in the last 1 or 2 years, they were able to reach these kind of performance measurements, and that's really absolutely great. Yeah, and already I'm at a conclusion and discussion. So in terms of machine learning tools, I think it's safe to say that although we are working on that for the last 10 years or so, the uptake and implementation of these tools is slow. Unfortunately, there's still no validated stopping rules available, so that you you cannot say when it's safe to stop screening, for example, with a prioritization tool. There are new approaches available, like combined approaches, but I think at the moment it seems to be the case that this might be an outdated technology. And I'm not saying it is, just that at the moment it looks like it is. In terms of large language models, it's really impressive to see how easy it is to realize that. As you could see on the numbers of studies that are available right now, the sensitivity measures are comparable, but should be better. But what is really impressive are specificity. Nonetheless, of these results, I have to say all of these studies are explorative and they are only retrospective studies. And most of these studies also use post hoc changes within their studies to improve their sensitivity or specificity. So in no way we are near a validation study, or we are near something that, for example, we at IQWiC would say it's safe to use them in a systematic review right now. But I think you could say that large language model probably outperforms systematic reviews done, for example, by moderate English speakers or by non-expert screeners, for example, if you used students. My thoughts on implementation of these large language models for the future is we at IQWiC, I think we are going to wait for software solutions that are available, because we are in no way able to program Python or incorporate APIs. That seems not technically feasible for us. So we would rely on software solutions that are available. What you read in the publications or in different articles is that there might be a combination of searching and screening. Not in these studies I presented to you, but some of them, there are some approaches that combine these things. I think we are near the solution that large language models could be the second screener, or could be used as an RCT filter. As I told you, I was really impressed with the specificities. So it could also be an approach to exclude obviously not relevant citations. In information retrieval, we call that knotting out garbage. Yeah, and my question was also, so we as information specialists, if we might be prompt engineers in the future, our task at the moment is to translate a PICO, a research question, into databases, to translate that. And I think it could be exactly the same task we could do for large language models, to translate these PICOs to that they can be used for large language models. Yeah, so these are all the references I used